Okay, and just need to go over some terminology. So first of all, the word solve means what?
Figure out.
Yep, so your answer is going to be some numbers, okay? Like x equals 3 or whatever. And you'll also be solving for y. Leads us to the next part of the sentence. We have two variables, okay? What is a variable?
A number.
It is a number. That's exactly what I was looking for. No, that's very important. A lot of people think a variable is a letter. It's not. We use it as a symbol. Okay, you can use anything for a variable. You could draw a picture of a house, and that could represent a number. It's just something that you put there in place of a number you don't know. So it's a number that changes.
Like 2x plus 7y equals
Yes.
3c.
So x and y would be two different numbers. We're going to be solving for two of them. In this class, we've only solved for one variable so far. And the word system means more than one thing, so there's going to actually be two equations. Basically, the way it works is however many variables you have to have that many equations to solve it. So because we have two variables, we're going to have two equations as well. And I'm going to teach you how to solve them. Okay, I'm going to jump a little bit to example 2. I was looking at example 1 on here, and I'd rather do example 2 first. Okay, so let me read this. So in case you guys need to know how to read this, we have 12x minus 9y equals 27. So right off the bat, you see two different variables, which I like your answer. They're numbers. So some number will go in for x and some number will go in for y to make this equation true. But it also has to work for the bottom, right? 8x minus 6y equals 18. The reality is there's only one number for x and one number for y that will make this work. Okay? So keep that in mind. So we have two equations with two variables. I'm going to show you guys how to solve this. There's many ways to do this. I'm going to teach you the way that always works no matter what. There's another method that I'm not going to go over just because it only works some of the time. I don't think it's worth doing that. So does everybody have this written down?
I have a question.
Yeah, what's your
So I'm
question?
thinking if
This method is called elimination, okay? That way it's called substitution. So let's go through this. Step 1. Make sure it's in standard form. I know that it already is, but I need you to write this down because when we get to some of the later questions on the worksheet, you have to do this step. Now, it needs to be in the form ax plus by equals c. Let me explain that. Basically, a number times x plus a number times y equals another number. Fortunately, for this example, it's already in that form, okay? We have a number times x. It doesn't have to be plus or minus. That doesn't matter. So it could be plus or minus. But a number times x, then a number times y equals another number. And both equations are in that form. So for step 1, make sure it's in that form, ax plus by equals c. Or ax minus by. Doesn't matter. Just make sure it's in that form. If it's not, you have to get it in that form. In a future example, I'll teach you or show you how to do that. We've already done that, actually, where we get x and y by itself. So it's nothing new. Make sure you write this step down even though it's already done for this problem. This step is to write down, fill in any missing coefficients. Now this one's already done. I'll go ahead and give you a clue as to what that means. If you have a variable, either x or y, let's talk about x first. What's the coefficient you can put in front of x? If there's nothing there. Like what could you insert right there? 1. 1. Yes. Now let's say it was negative y. What would the coefficient of negative y be? Negative 1. All right, that's what I mean by missing coefficients. It's either going to be one of those two, and you need that just so that you know, well, it's just basically a group of numbers. There's actually another way to solve these using matrices, but I'm not going to do that because we haven't talked about matrices. But anyway, it just goes back to the coefficients of the variables. But in this case, we already have all coefficients filled in, namely 12, negative 9, 8, and negative 6. So we don't need to do that. Okay, any questions about step 2? It's a little bit more, okay. I've kind of got a different way that I used to do least common multiple. I'm going to show you the easy way, okay. Determine the least common multiple of the coefficients of one of the variables. We're going to focus on the coefficients of x, okay? Now I did say for this step your choice, but sometimes students get confused when you're given more than one option. So I'll just tell you this, just focus on x, okay? If you don't want to worry about y. So somebody tell me, what are the coefficients of x in this example? For both equations. What's the first coefficient? Look at the system of equations. What's the first coefficient of x in this example? 12, thank you. Okay, and the other coefficient down below it? 8. Okay, now here's the real question. What does the word least common multiple mean? It's the opposite of greatest common factor, okay?
The least number.
It's the smallest number that both numbers go into.
Oh,
okay?
wow.
The least common multiple is usually bigger than your two numbers, okay?
That's got me confused.
The greatest common factor is usually smaller. Yes? It's 24, okay? Let me teach you how to get there. Listen up. Look at that. Take that off, please. Look at the biggest number between these two. Which one is bigger, 12 or 8?
12.
Okay, so the first thing you're going to do is look to see if the smaller number goes into it. If it does, then that's your least common multiple. For example, if I had 12 and 6, 6 goes into 12, that would be my least common multiple. But in this case, 8 doesn't go into 12, right?
No.
So what you do is you take your bigger number and you multiply it by 2. What's 12 times 2?
24.
Okay, now that you multiply that by 2, you check to see if both of those numbers go into that number. Do they?
12 plus 8 is 20.
12 goes into 24, 8 goes into 24. Now, if that didn't work, then you would triple your bigger number. If that doesn't work, then you quadruple it. You keep multiplying it until both of those numbers go into it, and that's how she figured out it was 24. So we're going to circle that, and we're going to write that equal to our least common multiple. That's what LCM stands for. So step 3 is just determining the least common multiple of those coefficients. Like I said, you can just always focus on x, and it'll always work. If you're interested in going down the path of looking at the least common multiple for the coefficients of y, I can show you that as well. It's pretty much the same process. Okay, so for the next step, we are going to make sure that both of these numbers turn into the least common multiple. So I need to turn 12 into 24. What number would I multiply the top equation by to get 24? How can I turn a 12 into 24? Okay, so you're going to multiply the top equation by 2. How can I turn 8 into 24? So you're going to multiply the bottom equation by 3. Okay? So again, you are turning these leading coefficients, you're turning these leading coefficients into the least common multiple. So this 12 will become 24, this 8 will become 24. So they both need to turn into the same number. Any questions on that? If you want to figure out what that number is, you can just take the least common multiple and divide. 24 divided by 8 is 3. That's how I know I multiply by 3. Gives me 24. Same for the top. 24 over 12 is 2. This down, notice we are taking the entire equation and putting it around parentheses. So the 2 is going to distribute to every single number, okay? We've learned the distributive property, but the way it works is it'll be 2 times 12, 2 times negative 9, 2 times 27 on the top. On the bottom, it'll be 3 times 8, 3 times negative 6, 3 times 18.
Where did you get the 2 and 3 from?
Okay, so we figured out that the least common multiple was 24. Did you get that part?
Yeah.
The fact that 12 goes into 24 2 times. I think
Right, so for the top equation, if you do 24 divided by 12, you get 2. That's the
Okay.
top. For the bottom equation, 24 divided by 8 is 3.
Okay.
So it's the number that you use to multiply that to get the least common multiple.
Makes sense.
Good. So now that we've done that, we're going to multiply everything on the top equation by 2. So that will become 24. That will become negative 18. That will become 54, just doubling it. Bottom, that will be 24, negative 18, 54.
Wait, so both the equations should be the same up here?
Well, I'll explain it in a second, but yes, it doesn't always happen that way.
Okay.
Okay, so let's go ahead and multiply that out. Actually, before we do that, I did forget a step. I'm sorry. You want to multiply the second equation by -1. So basically what it amounts to is this. If the bottom number is positive, then put a negative in front of it. Okay? If it's negative, then change it to positive. You basically want the top to, you want these to be different signs, and you'll see why it'll eliminate one of the variables. Okay? So instead of it being 3 times that, we're going to multiply everything by -3. And that'll actually change things, because then it will be more or less the opposite on the bottom. Right? In other words, -3 times 8 is what?
24.
-24. Then -3 times -6 is +18. That will become -54. All right.
By -1.
So that's what happens when you multiply. Make sure you write this out. I'm just distributing that number to each of those. So when we do that, going back to what you said, it would have been the same, but since we multiplied the bottom by -1, now the top equation and the bottom equation are the same, except they're flipped. Okay? Pretty crazy. So now that, I'll go back and just show that one more time. So basically what we did was we just took each number and we multiplied it in and distributed to each term in the equation to get that, just in case you were clear about that. Now, once you get to that point, you add the equations, and you add from top to bottom, just like you learned, in elementary school. So the first thing you're going to do is add your x terms. They should turn out to be 0 if you do it correctly, and you chose x to be your least common multiple. Since you multiplied the bottom by -1, that plus that's going to be 0. Now, normally, this won't happen. Normally, it'll be something like 3y plus 4y equals 7y. This is one that's going to happen on the worksheet, actually, but sometimes you'll get 0 for that. And then also for the last two numbers, they normally aren't like that. You'll normally get a number back like 7 or 8. For this particular example, 54 plus -54 is 0. So if you want to, you can also put parentheses around the bottom showing that you're adding each of those, but you're just adding from top to bottom. Okay? So we get 0 plus 0 equals 0. Does anybody know what that means for this problem?
It's 0 does equal 0.
0 does equal 0 when?
That's true.
Sometimes, never, or always?
Always.
Always. Yes. So, go ahead and write this step down, because usually you'll be solving for y in step 8. You'll be solving for the other variable that you didn't eliminate, namely the x was eliminated, so you solve for y.
I like this lesson.
Good. You like it better than
I don't like
scatterplots?
you need to read it and wrong.
Okay.
I just like solving. I don't know.
All right. Well, okay. So normally, like I said, you'd be solving for a variable here, but he pointed out 0 equals 0 always. There's no variable left. We eliminated everything, and we got 0 equals 0. Now, because that's always true, whenever you, in math, okay, it doesn't have to be 0 equals 0. Let's say you got 7 equals 7, or whatever. That is always true, right? A number is always equal to itself. When that happens in math, go ahead and write this step down for the future. Normally, you take a variable and plug it back into the equation. Okay, so since we don't have that, we'll do that in another example. Then for step 10, you'll solve for the other variable.
There's another step?
Yes, because there's two variables to solve for. There's an x and a y.
Sorry.
Okay. So anyways, guys, like I said before, when you get a number equals a number, listen up. When you get 0 equals 0, the answer is all real numbers. So for x, I'm going to write all reals.
For reals?
all reals, and y I'm going to write the same thing. And I'm even going to demonstrate why that is, because right now it probably doesn't make sense, but what we're going to do is plug any number you want to back in for x, and you get to plug in any number you want to back in for y. It's pretty crazy. Basically what that means is if it works for the top, it's going to automatically work for the bottom. In other words, both equations are basically the same. They're just written in two different ways. So you could literally pick any number for x, and you don't have to write this out. Just make sure you write that out. But you could literally pick any number for x. Once you solve for y, it will automatically work for the bottom, no matter what. So you could have chosen 7 here, solve for y. It will automatically work for the bottom equation that we got.
Wait, is that all the steps? Just 12 steps?
Yes.
Check back that.
And so if you were to plug that into the bottom equation, you get 18 equals 18. Going back to the original equation, I'll just get you guys to pick one, and I'll show you that it'll work for that one as well. All right, so let's pick another number. Any number for x you want. Just pick one.
12, not 12.
16.
Okay, I heard 7. We'll do 7. So we're going to write out 12x minus 9y equals 27 and solve for that. So instead of x, I'm plugging in 7. Okay, 12 times 7 is 84. Okay, how would you get y by itself from here? Okay, good. And what's 27 minus 84? Let's see, 77. Negative 57, right? Because 84 minus 27 would be 57. If you do it the opposite, it's going to be negative. So you get negative 9y to what we had. So listen up for a second. So when we solve for y, we got 57 over 9. She chose 7 for x. My point is, if you plug it into that bottom equation, it works out. It equals 18. So no matter what number you pick for x, you'll get a y value. They'll both work for the bottom. That's what happens again when two numbers equal them. Like if you get 3 equals 3 or whatever on both sides of the equation.